Let me get it to go. All right, if you want to say hi, Molly, you can. Oh, she can't hear us right now, but anyone wants to say hi?
Hi, Molly.
Okay. All right, so solving systems by graph. Okay? Solving systems by graph. So, when we solve a system, what do we find? Okay, where two lines meet, which is a point. Okay, so we kind of did a word problem yesterday, but you're very simply, you're just going to graph both equations. Okay, so where do I start on the first one? -5. Okay, so 1, 2, 3, 4, 5. All right, what's the slope? 3. So up 3 over 1. Now, how do I graph the second one? Start at 2, and the slope is 2 over 3. So up 2 over 3. So 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Okay, now I'm graphing the entire equation, but really when you found the point of intersection, you're done. Okay? Now the point of intersection is a point, which means it's a coordinate. Okay, so the confusing thing here is like people will want to say it as a fraction. You're not giving the slope, you're giving a coordinate. You're giving an x and a y. Okay, I will connect my dots. You don't have to, just to kind of help you see the point of intersection. So there's my line. There's the first line. Okay, and that, because I didn't graph it perfectly, but that dot is the point of intersection, and the ordered pair is what? Anybody name it?
Okay.
Anakin?
3, 4.
4. Okay? And so, simply put, the solution to the system is 3, 4. Okay? Y'all remember that from yesterday? We did one example, I think, and then went on. Okay? Now, several things to think about. If the slope was negative, okay, so you have to remember graphing. If the slope is negative, you will not go up and right or down and left. You will go up and left. Okay, remember negative lines have to go the opposite direction. So that's one thing to remember. Okay? Another thing to remember is when you're naming an ordered pair. Okay? So any ordered pair in this quadrant, these values will be what? Positive. Okay? Also remember on an ordered pair that you have to run before you jump. Okay? It is x, then y. Okay? You're not dividing, you're just naming a place on a graph. Alright? If I name a coordinate in this quadrant, x is negative, y is positive. So things to remember. Okay? If you name a ordered pair in this quadrant, both negative. If you name an ordered pair in this quadrant, x is positive, y is negative. So those are some remedial things to remember. Okay? Now, I felt like you all did a really good job of understanding yesterday, and there's really not that much to this. There's a couple of other things we need to talk about. And I want you to write the equations in your notes. I'm going to put some equations up here. You don't have to graph them. We're not going to take the time to graph them. But I do want you to write these equations in your notes. Okay? So, suppose we have or your goal is to solve this system. Now, you're going to learn some things about systems, and whenever, the better you understand, the quicker you get the answer. Okay? And so your goal is to solve a system. I'm going to teach you other ways to do it, but I really don't care how you do it as long as you can solve the system. Now, right now, you only know one way to solve the system, so that's how you will have to solve it. But there are other ways. Okay? I want you to think about this as a word problem. Okay? Somebody give me a situation. Not everybody wants.
What?
Somebody give me like a real world situation that we could model. Mumble, mumble, mumble. What? Nobody? Okay, let's do bank accounts. All right? This is Faith's bank account. This is Ty's bank account. How much money did Faith's bank account start with? $4. How much money is it getting a day? $2 a day. How much money did Ty's bank account start with? $1. How much money is it getting a day? $2. Where will they intersect? Okay, think about it. When will they ever, at the same time, have the same amount of money?
Never.
Okay, never. Okay, can anybody explain why? Sutton.
Because they're gaining the same amount of money each day.
Right. It's because their rates are the same. Okay? And so, if their rates are the same, they will never intersect. What is the solution to this system? And remember, in your notes yesterday, you put a solution to a system is the point of intersection, right? Something like that. That's what you wrote. Solution to the system is the point of intersection. What is the solution to the system? Anakin.
I think, yeah.
Now think, you've already given me the answer. And I guess I just asked the question again. That's my bad. What is the solution? Where will these cross? They won't. What is the solution to the system? No, then that means they cross at 0. Okay? Do they cross at 0?
No.
No. Okay. In your notes yesterday, you wrote something like, I'm going to paraphrase. All right? To solve a solution to the system is to find the point of intersection. Right? Did you all write that? Did I restate that appropriately? Okay. To find a solution is to find the point of intersection. Where will they intersect? Nowhere. What's the solution?
There is none.
There's not one. Okay? There's not one. Okay? Don't overthink it. Now, how we say this, your math words here, no solution. Now, if you put not one or can't, I mean, you're communicating the same thing. I would accept it. But there is no solution. Okay? Now, so what I'm telling you is if you recognize that without graphing, I don't have to see a graph. Okay? Now, don't think you can trick me on cheating, because, if they do cross and you didn't graph, I know you cheated. But, like, if I see this, okay? Now, let's say this for all of them, okay? Anytime you have a system where what is the same? The rates are the same. The answer will be no solution. Okay? Are you with me? So you technically don't have to graph these. But let's graph them anyway, because some of you will forget, and let's see what the line looks like. Okay, can anybody guess what the lines will look like when I graph them? What? Parallel. So let's see. First one's going to start at, well, I'm starting at 4. I'm going to call the top one the first one. And then up 2 over 1, up 2 over 1, up 2 over 1, down 2 left. Whoops, about to. Okay. Second one's going to start at 1 and go up to right 1. And since the slope is the same, these two lines are parallel. And they will never cross. Okay? So you did write the 2 equations in your notes. You're probably going to want to say slopes are the same, no solution, their graphs are parallel. So like that would be your notes part. Okay, that would save you from graphing. But you want to put in a note that since the slopes are the same, they are not going to have a solution and the 2 lines are parallel. So not every system intersects. Okay? Not every system intersects. Okay, do not write this problem down. Now, notice this, okay? Notice this problem, and then I go backwards and notice the problem we started with. What's the difference? What's the difference? Yes?
Instead of equals y equals a number.
Right, okay? And I like to restate it and say, these are not solved for y, these are. If you remember your unit on graphing linear equations, to be able to graph them, they had to be y equals, right? So if I give you a system that's not y equals, how are you going to graph it? What? You got? Huh?
You
You can. Anakin?
have to solve it.
You have to solve it for y. Okay? Now let's go ahead and talk about that. I would actually not have you solve this system by graphing. Okay? But since graphing is your only way, what I want you to put in your notes is just put solve for y, and let's review solve for y. Because if you get one that is not solved for y and you only know how to do graphing, so we're only going to do the first equation. And I'm also going to tell you there's a better way if they're not solved for y to graph them. So we're actually not going to solve this system. We're just going to kind of add in a review on solve for y. All right, who remembers what I need to do when I'm trying to solve this for y? William, you're trying. You want to take a shot at it?
I think it's supposed to
Take a shot.
I'm supposed to not just looking for I don't know.
Okay, Christian? Yeah, well, you want to move the x. You're going to leave the y. The 2x is positive. That's why Christian said subtract. So let's subtract 2x. Okay? What that gives me is 3y equals 6 minus 2x. Now, keep in mind that 6 and 2x are not like terms, so I just keep it as 6 minus 2x. Okay, Anakin, you want to finish it?
Yeah. You divide 3.
By everything.
Yeah.
Okay? How's it going? Okay? So here they cancel. 6 divided by 3 is 2. All right? You want to, if you were going to graph this, you want to keep your slope as a fraction so you can see your up and over motion. Like if you divided it, you would get 0.6. Keep it as a fraction so you can see your up and over. And now could we graph it?
Yeah.
Yes. Okay? So that's a review for solving for y. And I want to show you one more example. And then I'll let you all practice. Okay, here's your one more example. Let's put it in our notes, just the equations, and we'll be able to answer it without graphing. So let's say y equals 1/2 x. We should probably do some negative slopes, but it's okay. Minus 1. And let's do 2y equals 1x minus 2. Does anybody know the answer? Okay, so let's back up. Is the first one solved for y? Could I graph it? Hold on just a minute, sir. Yes. Gary's shaking your head, yes. Is the second one solved for y? No. So what would I have to do? Solve it for y. Okay, with our current knowledge, we would have to solve it for y. Sutton, you know the answer? What's the answer?
No solution.
No.
Nope.
Okay. Anakin?
The answer is 1/2 x minus 1.
No, the answer is the solution to the system. Now, you gave me the equation to solve for y. Does anybody know the answer to the system? Huh? Everything.
All solutions.
All solutions. Okay? Here's y. So let's go ahead and solve this one for y. What do we have to do to solve it for y?
Divide 2 by
Yeah, if I want y equals, it's already 2y, Tambrin. I just want to get y, so I'm going to divide by 2. Okay? And look at what I get. I get y equals 1/2 x minus 1. Okay? I end up with the same equation. Okay? So think about it. Now, what's different from this one and the no solution? Because they do have the same slopes. So think about it. If we put money, like money in the bank account, right? Or running a race, this would be like where they're side by side all the time. Okay? Their bank accounts are the same all the time. So these two lines, even though they have the same slopes, but since they also have the same intercepts, they will cross everywhere. Okay? They will cross everywhere. And if I graph it, I start at -1 and I go up 1/2 for the first one. And the second one will start at -1 and go up 1/2. What are they doing? They're crossing everywhere. So, Christian said everywhere, which is true. The math word we use here the most?
All solutions.
All solutions. Okay? Because they cross everywhere. Slopes and the y-intercepts are the same. Now, when you think about work and me trying to save you work, nothing would make me happier is if you saw both equations and noticed they were the same and didn't graph them. Okay? Because if you don't graph them, but you can still rationalize the answer, that's okay too.